All right, welcome to part two. In part two, we're going to put a lot more love into this. We're going to give them the ability to attack and patrol on their own. That's kind of the gist. But we also need to expand this so that way their movement is also, not just movement. What do we want to do? First of all, let's right click and create, and then let's just have a new blend tree that's going to be called rotation or turning. This is going to come in handy later. And then let's create a empty, and it's going to be called attack. There are more things here that unfortunately I do not have time to cover because that first video already took 20 minutes. What we're going to do is let's connect them together and ask yourself, from what state can you attack and from what state can you turn? Well, from movement you can attack, from turning you can attack. I'm actually going to say from movement you cannot attack. And we're going to make this triangle. From turning you can go back to movement, and from attack you can go back to turning. There we go. Now what are the conditions for this is the question. Let's add a parameter here. It's going to be a trigger, and it's going to be attack. And over here we're just going to add our condition, which is our trigger, attack. And then for our turning, we kind of need to think about this more. So how I want this to work is when you click on a target, such as this enemy over here, our character will rotate to face them and then throw fireballs at them with our fireball attack, which is over here. And there's a bunch of other stuff if you wanted to continue with this. In fact, I might make it an assignment because, again, I love RTS games. Joke's on you. Maybe I'll make you make it so you can take damage. I don't know. It shouldn't be too hard for you guys to do, but goodness, I should have named these better. Here you go. This attack. You can throw the fireball that we're working on. Okay. Yeah. So let's go straight into it. Let's make it so when we right click, first of all, they will just rotate to face the correct direction. Then, once they are facing the correct direction, they will initiate their attack. Okay? So, let's go back to Commander, and let's start by doing our thing in here. So we need a public, not a public, what am I saying? We need another if physics raycasts, if not physics raycast, cam worlds array, out our hit object, out its distance, and I don't know why I said out again, and static utilities dot, and then let's control click. We don't want to be able to attack ourselves, so let's make another one here, and it's just going to be like this, and it's going to be called attack layers. Attack layers, just like that. And if it fails, then return. But if it didn't, then for each monster, oh, whoops, oh god, monster, for each monster, then let's tell our monsters to try attack, and then let's ask them to try and attack our hit object. And let's give them everything here, because we do not really know what they're going to want to do with it. And that's honestly something you can do with move 2 as well. But yeah. So we've included it in here. What we want to do now, we need to, first of all, rotate to face our object. Let's write this down. Rotate to face object. And then we need to attack. The first thing that comes to mind for me is asynchronous programming. And I think that that's a strategy I want to go with. Previously, we've talked about coroutines. Asynchronous programming is interesting as it doesn't work on all platforms, which means no more WebGL, at least as of 2023 when I'm saying this. Bright side, multi-threaded, better than coroutines usually. Another advantage is we can mark everything as a task, and it makes the whole format of this a lot neater. I'm going to do it this way. Oh, it's also better on memory. So we're going to have our public async void to make it asynchronous. And now what we want to do is we need to create two more functions. Private async task, right? And a task is just something that can be completed. It can be yielded or waited until it's done. We're going to say a task, and it's going to be a rotate to target. For a task, we need to import system threading. Okay. I'm not sure if it needs to be async, to be honest. No, it does. It does. What we're going to do in here is, because it's a task, we can now say await rotate to target. Because it's a task. You can't do this if it was void. See? Okay. So what we want to do is we want to say await. Pretty much, we want to rotate every frame. First of all, we need to understand where we are before we do anything else. Let's actually start by going to Unity for this one. And let's open our turning. What we want to do in here is let's create a new parameter, float, and then turn. And what we're going to do is very straightforward. We're going to add 1, 2, 3, 4 parameters in here. Turn off automate thresholds. The dot product is very special because when you have two vectors and you know that they're normalized, what you can do is you can draw like this. Or, sorry, you can get the angle between vectors, where if you have this vector and this vector, you would have 0. If you had this one and this one, you would have 1. And if you had this one and this one, you would have -1. That might be a little confusing. Go look up dot product if that's confusing. Pretty much, if our character is facing this way, and we want to look this way, we're going to get a value of 1. And if our character is, we're going to get a value of 1. The problem with this is, if we wanted to turn left or right, which way is left and right? There is none. Right? So what we can do, instead of getting the dot product of the forward and where it's trying to go, what if we take the dot product of the forward and its right vector? And by doing that, let's say we wanted to look over here. This is 0, right? That means we're directly forward is now 0. If it's to our right, then it's going to be 1. And if it's behind us, it's going to be -1. If we're over here, it's going to be 0.5 negative. And if we're over here, it's going to be -0.5. That's the idea. So by doing that, we can do this. Disadvantage, though, is that also means that behind us is 0. So we need to tell the program to properly differentiate which way we're supposed to rotate, which could be easier said than done. So what we're going to do, first of all, let's actually change what we're doing in try attack. And let's pass down another parameter. It's going to be our vector 3, and it's going to be our normalized hit point. And the reason we want to do this is because if we're going to normalize it for every enemy, that's a lot of math that we should avoid at all costs. So hit point, normalized. Okay, and then let's pass it down as a secondary parameter. It's like significantly better for the CPU than calculating it again and again. But let's now take this in as a parameter. Okay, no errors, no errors. Great. And then let's pass it down to rotate target. Vector 3. Pass it down again. Okay, and then we're going to get our float angle is just equal to our normalized hit point subtracted by our, not subtracted, I don't know why I said that. It's going to be the vector 3 dot dot. And it's going to be our transform right and the normalized hit point. It's unfortunate. This is expensive math, but we have to do it to make the game look good. So deal with it. Now what we need to do is we need to query, unfortunately, every frame and check to see if we have rotated. I guess that's a reason why this should not necessarily be asynchronous. Is because coroutines run with time. Async doesn't. Okay, I'm changing it. I actually don't want to do this way. I'm going to do an enumerator. It's easier as well. Sorry. We're going to change this to be start coroutine. Which is unfortunate because now, if we do it this way, that means we have to say that attack is in here. Unless this was also an enumerator, and I don't want to make this one an enumerator as well, because then we're putting the load on another object. Yeah, so we're going to rotate towards, and then at the end, then we're going to start our attack function, private enumerator, or maybe it's a function that's called start attacking or whatever. So private void start, or just, let's attack once for the sake of attacking. What we're going to do, we have our angle, and we want to rotate every frame. So we're going to create a do while loop. And let's say we're going to do while our angle is greater than or equal to 0.05. But it's not just 0.05, it's going to be the absolute value, mathf.abs, of our angle, 0.05. And the reason why I'm saying this is because if we look back here, we're looking at this range over here, and we're taking the absolute, which means it's both sides of this, of the 0. And pretty much we're saying if our target is in this range, this vector here, we've rotated enough, we're chill, like it's going to look fine. I'm actually going to reduce it a little bit because we can get it pretty precise. And yeah, so this is going to be our error, is what it's called. Great. And then this bit, we can copy paste it into our do part. Oh god, I've gone here. Copy and paste it into the do part. And do that. And then let's yield return null. Wait until the next frame. And then we also now need to pass this down to our animator so that way it can handle this correctly, which for some reason I did halfway and then I stopped. So let's go back to here as well. He's gonna be like, oh, he's jumping around all the time. Anyways, we're gonna press on turn, and let's go to moving, and we're gonna go to turn left, plug it into the top two, turn right into the bottom two. So that way we have a slow turn and a fast turn. Turn off automate thresholds, and set the left here to be -1. Whoops. -1, -0.5, and then we're going to have 0.5, 1, and then the speed is going to be half for the slow speed ones. Okay? You can play with the speed more if you feel like that's appropriate, but you'll see that they rotate. Okay? And this looks kind of stupid, especially here. So what you need to do is make sure that on your animations in the motion section you have root motion on. We talked about this in the first part. This, for specifically turning left and turning right, is where I have it enabled. So that way it rotates correctly with its animation. And then also make sure that your avatar has apply root motion on it, your animator has apply root motion on it. So that way it works correctly. That should be good. And we'll see that if our turn is 0, it looks really dumb. He's kind of like lifting his feet a little bit. I think what's going to happen is if the turn is 0, we're probably going to push him off. So let's go to our base layer, and let's say that if the turn is less than our error, which is 0.01, let's go back to the movement loop. But if the turn was greater than 0.01, we're going to go to turning. And then finally, if our attack condition triggers, then let's go back to attack. And let's actually delete this one because it doesn't make sense to come back. We're going to send it down to movement again. And in movement, we're going to turn off has... yeah, no, it should just go through. Attack should always transition to movement. Turning should not have an exit time. It should immediately play. Has exit time means whether or not it should play instantly. So we want turning to attack should play immediately. Movement to turning, that kind of depends. I think we do not want it there either, or here, to be honest. Because if we want to do like rapid actions, it might feel a little clunky. But we'll see. This is probably the only place where we do actually want it. But we have no parameter because it should be immediately going 1, 2. Okay. Yay! We did it! So, what we can do now, let's go in here, and we need to pass it down to our animator. Animator, my animator dot, and then we're going to set float, which is our static utilities dot, and then our idle anim, not idle, and we don't have it. Duplicate 2 more, attack and turn. Cool. And back to monster. We're going to do turn anim ID, and it's going to pass through our angle. Remember that our angle is this. It's the right. So when it's 1, we're turning to the right, and when it's -1, we're turning to the left. The only issue is what happens if the point is behind us. We can actually see this now at this point, as a matter of fact. But we probably need to store our rotation as a function so that we don't accidentally queue it more times than we need to. So let's go to the top here. Private coroutine is rotating. Okay, and let's pass it through. Is rotating is equal to this. And then if you try to attack, and if is rotating, or well, we can just say is rotating dots or stop coroutine is rotating. But I think that we do have to say if is rotating is equal to null, if I'm remembering correctly. Check if it's null, and if it is, then destroy it. Yeah, and then over here, let's just make sure that it will be null when we're done. Okay, and then let's call our attack function. And what attack is going to do is really quite simple. It's going to be our myAnimator, and it's going to be our start attack or set trigger. And we're going to set our static utilities. And it's going to be our attack animid with our angle. Not our angle. There's just going to be an attack animid. It doesn't take a parameter. I don't know what I'm talking about. Great. So now we're attacking. And again, you can go further with this. Make it so it's rotating with the character and it's always firing. This will not rotate. This is nothing. But it's not bad. It's a good start. Let's give it a try before we work and try to solve this issue. So back to Unity. Here, let's press play. When I right click, they should not move, only turn. We got a null reference exception. The coroutine is null. I knew it. I knew it. I knew I'd mess that up. You have to say it's not null. If it's not null, then stop the coroutine. Silly, the silliest of geese. Goddamn. Okay, I accidentally clicked, I guess. Guys, come back, please. Okay, and let's ask them to rotate. That one is not cooperating. Let's ask him to rotate. Oh, God. Interesting. I guess that was them attacking? I don't know why they T-posed. Let's ask them to rotate to here. Okay, whenever they attack, they T-pose. That's good to know. Ask them to rotate. Oh, look, they're turning. He's not working appropriately, is it? Oh, I know what it is. I totally know what it is. Over here, when we're done, you put this to 0. And as a matter of fact, let's actually create another function here. A private void stop rotating. And let's just take this and do this with it. Pass this through, just in case, because like, I guess nothing can cancel a rotation right now, but it could happen in the future. And then this way we say stop rotating up here. It might come in handy later, that's why we're doing it. Okay, don't know why I left clicked there, but if I right click over here now, look at that, they all turn. Okay, I right click again and they do not turn. Some of them turned. Okay, is there a math error? If the absolute value of our angle is greater than 0.01f, then they should all rotate. I see no issue with that. What's interesting is if I click again, when we stop our rotation, it doesn't appear like our animator is setting our turn animid to 0. Because the ternity should be 0, but that's not the case. What's even more curious is it seems like a negative rotation, they just don't get, they don't care. Maybe that's what it is. Where have I made a mistake? Okay, so we have our angle, we take the dot product from the right to our normalized vector. Maybe we should print our angle just to see what it is. Actually, no, we're already seeing it. It's over here. And when we wait until the next frame, the absolute value, the positive value, is greater than 0.1, then we continue this. But this is an absolute, so that should be fine. Is the animation itself broken? In here, we have turning left. Okay. If I give up control over turning left and right, it's interesting because it looked like I did not have control there. See, the attack trigger is going through. Oh, crap. It can't go from moving to attack because the condition for turning is true. That's not ideal now, is it? So instead what we're going to do, let's add a boolean and let's call it is turning. This is cringe, but we have no choice. Let's plug it in here. If is turning is true, if is turning is false. Sometimes that be how it be. What we do now, we'll go to settings, not settings, static utilities, duplicate, and let's create a is turning ID. This is turning. Make sure it's spelled the same as in Unity. Verify. Don't make silly oopsies. It's, hold on, was that lowercase? I wish Unity would load instead of auto. Oh, you know, I love autosave, but I also hate it. Lowercase I. Okay, there you go. We got it. Let's head over to monster again and let's get this working. When we stop rotating, let's also, I guess we don't actually need to do this anymore. We can just say set bool and then is rotating, turning is anim turning, and then set it to false. And let's just do that in both of them. That's it. Yeah. So now, oh wait, I need a true. Hold on. Up here, at the start, set it to true. That's better. So now, we should have that working more appropriately, but there's still an issue. And that was an interesting way to turn there. Okay, well, I don't know why the fireball's a T-pose. That's rather concerning. You can see they're all firing their T-poses. You'll see that if I click like over here, they do rotate to face it. If I was to click like over here, they rotate to face it. But if I were to click on some point behind them, per se, over here, you might see that they are not rotating to face it. This is because the right vector of them, right? So they, to the right vector, and like if I click over here, yep, that just seems peculiar in the first place. We're taking the normal from the transform right to the normalized hit point, and that's a blunder on my part. We can't just get the normalized hit point. What the hell does that do for us? It has to be a normalized hit point from where we are. Silly, silly Gabe. It's not this. Not this. Go back to try attack. Delete this. Unfortunately, what we have to do is we have to say our position, transform.position, subtracted from our hit point, hit object.position. Okay, but the order's flipped. B minus A, so that we were moving towards that point. Okay, and then we need to take the normalization of this, which is unfortunate, but I think that's our only choice here. Because the vector was in the world origin instead of local origin is what was happening. So now it's based on where it is instead of where the world is. But we're still going to come to the same issue here in a moment, or a similar issue. And there you go. Now they all appropriately are turning around to face the points. There you go. They are very cringe with it, to be honest. But you'll see, like, if I clicked behind this guy, oh, he did turn correctly. There you go. Oh, never mind. Maybe the math just works. If I click 100% behind them, I don't know. I'm just waiting to see if one of them. Okay, no, it just works. And look at that. They hit them with the T-pose. God damn. Okay, the attack animation T-pose is because there's no animation motion in here. So let's put in a motion. It's going to be called throw. That's that's it. Let's actually find our throw animation. It's in our trigger section here, throw. And what throw is going to do is really quite simple. Let's add an event, drag it to the end here, and we're going to say that it will attack. Okay. Do we have a thing here for attack? Let's say spawn fireball instead. Okay. And then we can actually pass down parameters as well if we want. I was originally planning on showing you that worked, but no, not enough time. Not enough time. Anyways, make sure you have the name exactly perfect. See, I made a typo like a clown. I'm going to copy and paste the name. Spawn fireball. Let's move it to be with my other thing here. And generally you have another file for this kind of stuff, because it can get annoying. But now when we spawn our fireball, it's going to be really straightforward. Let's instantiate, and let's create a prefab. And again, this is what I mean. It's like, it's just a review of everything we've been doing. And if you've been paying attention, you should flyweight stuff now, because your enemies can start to get really big really fast. Anyways, we have our fireball prefab. Let's instantiate it. We're not going to do anything to do with damage today. That will probably be homework. But we're going to set our transform position with our quaternion identity, so we have no rotation. Capital Q is better for the computer. Fantastic. We've spawned a fireball. What we do need to do, though, is we need to be in control of that fireball and making sure that it moves. This is something that I actually forgot to do that's occurring to me now. My bad. Let's change this to be a rigid body instead of a game object, so life's easy. And then let's cache it. Rigid body projectile. Okay, and what we're going to do is really quite simple. Projectile dot, and then add force, and it's going to be in our forward vector, so our transform forward, and then it's going to be multiplied by our force, however strong you throw it. I don't know, these guys are big, so let's just say 100. I'm lazy. You can make a variable for it, I suppose, if you wanted. And then we're going to say force mode impulse. That's it. And then let's go over to our projectile now in the prefabs folder. On our fireball, we need to make sure that it has, first of all, a rigid body, and second of all, let's turn off gravity. Fantastic. Turn it on to continuous, so it's a little bit easier to read. And then let's put it onto trigger mode, so it's a trigger. Generally, bullets are triggers. Fantastic. Okay, we've got all of our stuff. I'm actually going to go back to attack animation because it's occurring to me I did like a dumbass. Let's press back over here. I put the event, so in the event section, I put the event at the end, but he doesn't throw the fireball at the end. I don't know why I did that. He throws the fireball like way, way, way over here. So, and fireball, right? So let's move this to here. Fireball. Okay, great. And I made another stupid, god damn. What we need to do is serialized field, private, transform, and it's going to be our fire point, because we don't want to just spawn it from the middle of us. That would be really dumb, like super dumb. So we're going to say fire point position, and it's going to be fire point dot rotation. Okay, and then when we add our force, that's still fine. We can say firepoint.forward if you really wanted to be technical here. But I still think having this be our transform forward is more appropriate, especially if you want to have them like, maybe you want them to look somewhere specific. This can cause issues. I'm just gonna say it. This could cause issues if it's like, okay, what we're gonna do, we're gonna prevent any issues. I'm just gonna show you. Vector 3, look at point. we're going to chuck it in down here. And then when we set our target like this, we're going to say that our look at point is equal to our normalized hit point. Just like that. But honestly, we should do this equals, just like, it's a little bit better, I believe, for the computer this way. And that way we're not like passing down a variable, it's just going to be deleted. Oh, I deleted too many brackets. Like a dummy. There you go. Delete this. Delete this. Too many brackets again. Great. And now what we can do is, when we add force, we're adding it to the look at point, which is where he's actually trying to attack. There might be like a small, slight rotation issue here. I'm too lazy to fix that, but pretty much just, you'd have to almost normalize it again. But instead of transform position, it would be your fire point position. Or instead of doing transform position here, you would do fire point dot position, which honestly, you wouldn't lose much from doing it that way. But your look at point would be wrong regardless, so just do transform position. Okay. So we've got our public void spawn projectile, spawn fireball, whatever. It does its thing. It's gonna work. Looking good. Let's press on our monster. Let's open it in prefab view, and let's apply our prefab fireball. It's fire point. This one's gonna be a little bit strange. When it attacks with our attack, I believe it's coming from its right hand. So we need to first of all identify its right hand. Here we go. We have our right or attack point. And because it's bound to the bones, it's actually going to move it with all of our bones, which is fantastic. And this is a really actually phenomenally rigged model, which is great. That'll make our life easier. But we have our right hand and our fire points. Maybe we want to move it over a little bit more to the center. Okay, and there's no time like the present to find out the terrible mistakes we've made. Let's pass it through our attack point. And we don't actually have anything to do with health, but now we can try it. You'll see that if I right click, they will attack, and those are some fast moving fireballs. There was nothing wrong with that though. Let's decrease the speed on those. God damn. Like 1, just so we can see it. And let's also pull over the game view at this point, because I believe we're done with the animator for just now. Okay, right click. And turn off gizmos. We get our fireballs. And you can see what I mean. The fireballs do not move towards the ground at all. I mean, maybe not a terrible thing, given the circumstances. But there you go. Fireballs. And you'll see that it looks like he is throwing them. Honestly, many improvements you can make at any point, you know, especially if they move faster, it'll be harder to tell. The particle system could be improved. It's not even a particle, it's actually just a quad. You could optimize it at the Kahoozy. Many things you can do here. That's not what I'm doing today, though. Today I'm just showing you to do stuff. So, that concludes part 2. And you're like, oh my god, there's another part of this? And I'm like, yeah, I don't know why I thought I'd do so much with you guys. So, the final part, we're going to just add states to this, so that way if we don't interact with them for some time, then they're going to just start doing their own thing.